Hi guys, I'm Vincent Kanumai. This is EasyElimu channel. I'm going to take you through Form 4 mathematics and I will be taking you through the topic of integration. Stay tuned as I welcome you to learn with me. From chapter 8 of Form 4 mathematics, we saw how we handle of getting and obtaining gradient of different functions in differentiation. And now we want to go back to the functions which we had after having the gradient. For instance, being given a gradient function as 2x and be asked to find the equation of the function which gave rise to this, then the equation of the function, it means you have to reverse differentiate the gradient function. And if you do that on drawing, you will find that if you have this 2x, it can still be a function in case it passes through that line. So if it passes there, we can say this is the line of y equals 2x. But other lines can be found by taking the intercept of the the y-intercept of the y-intercept of the function. So if we take the y-intercept of the function, we can say from the equation of a straight line, we say that y equals to mx plus c. If you have y equals to mx plus c, and here we have 2x as our m is 2, then it means this. Our c, we can find it from here, and that is what will give rise to different kinds of graphs. We can have c as a quarter, we can have this c as 2, as 10, as -5. So having different kinds of them, you will find they will give rise to different kinds of graphs passing through the same plane, but they are parallel to each other. So you will find they will give us graphs. So this one has made 6, 2x plus 8. This one can be 2x plus 5. This is 2x plus 2. So you will find they are of different kind. What is only differentiating them is the c, or we call the y-intercept. C is just a constant representing the y-intercept. So we can say that from chapter 8, we did say that if you have y equals to 2c, not y, but the gradient function whereby you have dy over dx giving us 2x, we found out that the equation of this line was equal to y equals to x squared plus c. Any equation having this one, we said, before you come to it, we had already an equation looking like that. So if you have an equation y equals to x squared plus c, it will give rise to this. And so many of them that appear to have the form of y equals to mx plus c, they will take the form of this gradient, and their equation of the function will take the form of y equals to x squared plus c, or may have a coefficient of a. So for example, having find y if dy dx equals to 4x cubed, then if we have been given this way, to find y, you will have to do what you did in differentiation the opposite way. In differentiation, we remember we said that if you want to find dy dx, in case this was the function, you will take the power you multiply, and then after multiplying, you subtract 1 from the power. But here, you will take as it is the function of this one, which is 4x, but the power you add 1, so you take 3 plus 1, then you divide by the new power. And if you do that, you are going to get 4x raised to 4 over 4. And that is going to give you x raised to 4. This is what we have as the function of the gradient function of 4x cubed. This is what we have in example 2. You're having 8x cubed, that of a polynomial, plus 3x squared plus 4. Actually, remember this one is having plus c because we have that one as a constant of integration. So plus 4x plus 3. So we need to find the value of y. Given this one is dy dx. What is the value of y? The value of y will be obtained by doing the same thing. That is, we do the reverse as we have done. So doing that, we shall get 8x3 plus 1 over 3 plus 1 plus 3x 2 plus 1 over 2 plus 1. Then we add to 4x 1 plus 1 over 4 plus 1 plus 1. And then we add now these 3. We shall have to introduce x because this x was 0 initially, but we are now adding 1 and then we divide by that power. But remember, because we are integrating, we shall add a constant of integration because we don't know what is it. So on adding, we shall see what it comes to. So we shall find our equation y is going to be 2, because this is 4. 8 divided by 4, you're getting 2x raised to 4 plus, here if you do this one, you will find this will cancel each other and you remain with the x cubed plus this one is 2x squared plus, here it will give you 3x plus c. And this c depends on the term of what you are being given. So here we shall have that one as our equation of the function y, on which the gradient dy dx was obtained, on which this gradient was obtained. In general, we can say that if you have been provided with dy dx as being xn, then, or let's say even, let us start there. Then it means if you want the value of y, then you will have to take that xn plus 1, then you divide by the new power, which is 1. And if dy dx is equivalent to axn, then y is equivalent to axn plus 1 over n plus 1. And that is how we can find the integration of different equation we have been provided with as the gradient function. Welcome back. We are going to learn about definite and indefinite integral. And in this section, we are going to see how we can find the exact area of given curves under a given condition. For example, if we have a curve of the form, we saw that if we have been told this is x equals to a, and this is x equals to b, if we have been told to find the area between x equals to a and x equals to b, we say that we can find it by either using trapezium rule or mediordinate rule. And here, we can use to find the exact by taking the medianate rule, which will be just below the curve. Now we take the area of the medianates below the curve, whereby this is h, 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 h. You sum up all the area of, if this is y1, y2, y3, then it means that you will sum up all of it. So it will be from this section of x equals to a to x equals to b. You sum all the area here which are below or underestimated under the curve. You sum all the areas which are underestimated under the curve, like say they are h, y1 plus y2 plus y3 up to yn, which you will have. So if you sum all the areas running, then after doing that, we also do overestimate the area so that we can now find the area between the two. After underestimating, now we come to overestimate. If this is the curve here, we overestimate this way with the same h. Now we estimate in that way, and then also you find the mediordinates. And also you do, this was of underestimation, underestimated area. Now we do another one, we do sum, that is a symbol of summation. Summation. Now we sum another one with the same height. Then we sum that of the overestimated one, which will have now y1 running from the overestimated part to the lower part. So y11 plus y22 plus y33 up to yn, whereby those y11 are now the new heights or the new mediordinates of the overestimated area. If you do that way, you will be getting the area of that is the area of overestimation. Area of overestimation. So from there, if you need the exact area of this figure, then you will have to take the difference between exact now area which we need. You take overestimated area minus underestimated area. What do I mean? You take this area which you have found from overestimation, then you subtract that one. Whatever you will find in between is the exact area of this area under the curve here. But that is still, sometimes it may give a lie if the curve is more irregular. If the curve is much more irregular, it may give us a wrong answer. So the best thing we should do if we have mediordinates like this, we do reduce them, in that the mediordinates are only smaller in size, in that we may have of the same height, that is y, but here we only have dx. A very small change in dx. So in that case, if we have that way, then to find the area of this part, we will take the summation of y, then with respect to that dx we multiply, and then we will be getting the area of each of them in that case. And that one will be accurate because the length has been reduced to minimal. But we can find the area of given curves, exact area of given curves, using another kind of formula. In case you have been provided with y as the equation, for example, y equals to 4x squared plus 3x plus 6, then you are being told to find the integral of that one, or the area that the is between x equals to 1 and x equals to 3. Then to find the area of that one, it really means we have to find the small areas under the curve. If this is the curve, for example, if that is the curve, then we have to find very minimal areas, very small areas under the curve. We can find the integral of this equation, whereby this is the equation we are talking about, y, and it is from x equals to 1 to x equals to 3. But before that, we can find a definite integral or any kind of integral when we have been given some kind of limit, in that if we need to find the integral between these, let's say first this one is a and this one is b, and we need to find that integral there, we can find the integral or the area under that curve by integrating this curve from x equals to a to x equals to b. I mean this, if we need the area of that curve from x equals to a to x equals to b of line or the curve y, then this one will be integrated along with respect to what? It is integrated with respect to x, because we are having x is the one which is much more varying from a to b. So we are integrating with respect to x. So if you have that kind of integration, whereby you have the limits like a and b here, this is what we refer to as definite integral. But in case you have been given any kind of integration and it has no limits, for instance, this one we have said is definite integral, and in a place where you have been given any kind of integration but it has no limits, then know that one is indefinite integral. It is indefinite integral because it has no limits. So for our case here, we have been given the limit from x equals to 1 and x equals to 3. So we have to find the area under the curve where x is 1 and y is 3. So the interval in between and the area covered in between, we need to find it. And we shall find the integration of y with respect to x, of which now our x was provided was 1 and our b here was 3. So in that case, we have from 1 to 3, and remember here we have 4x as our y, or I can write it first. From a to b of y dx. But this one we have been provided is integration where a here, our a is 1 and our b is the maximum one, which is 3. And if we do that, we replace y with 4x squared. Actually it's 4x squared plus 3x plus 6. Then dx. If we integrate, we are going to find this one. We said integration, we shall add to the power 1 and we divide with the new power. So if we integrate for the first term, the first thing you do here, you integrate. On integration, you will integrate, you will find is 4x, 2 plus 1, you will get 3, and then you divide by the same power, plus 3, this one will be 3x, but is 1 plus 1, you will get 2, you divide by the same power, and then you add to 6, but it is having x raised to 0. So if you add 1, it becomes x. But remember what? We have a constant of integration. After integrating, you will have a constant of integration. And then after integrating, you put what you have found in a special bracket as this. And then at the end of it, you put the limits, starting with the upper limit at the top and the lower limit at the bottom. So after that one, we replace what is inside the value of x with the 3. And on replacement, we shall find here 4x, and x here we have said is 3. So it will be 3 cubed over 3 plus 3x, but x we have is 3, so it is 3x squared plus this one is over 2 plus 6, 3 plus c, the first replacement, and then we subtract. The lower limit means after handling the upper one, we subtract the lower limit. So the lower limit means that way, so we are going to subtract 4 multiplied by 1 cubed over 3 plus 3 into 1 square over 2 plus 6 into 1 plus c. That is what we are going to find. So on doing that, we are going to have the first one, the first bracket. This one is giving me 36 plus 13.5 plus 18 plus c minus, let's open, this one was a bracket. Let's just open that bracket, so it will be 1 cubed is 1 by 4 over 3 plus 3 over 2 plus 6 plus c. So on addition of this, I'm getting here is in the bracket I'm having 53 over 6 plus c, and here 67.5 plus c, but here we have a subtraction sign. So we need to find out the difference between the two, and we shall see that if we open here the bracket, we are going to get 67.5 plus c minus 53 over 6 minus c, because this one will open, and then we are getting that, but this plus c and minus c cancels out, and then we remain with the 67.5 minus 53.6, and we are going to get 58 and 2/3 square units. That is the exact area of that given integral from x equals to 1 to x equals 3. That means now the area under this curve is 58.6667, or 58 and 2/3 square units. So we have seen with that one we can find the area of a given curve using the limits, and also we can find the integral of any given curve without the limits. We can find the integral of any kind of a curve without a limit. For instance, we have find the integral of 4x cubed plus 6x plus 3. For this one, we integrate with respect to dx, and we shall find 4x cubed, it shall give us, actually it's going to give us 4x raised to 4, because it is 3 plus 1, and then you divide by 4, plus 6x squared over 2 plus 3x. But remember, after integrating, we have a constant of integration. So you put that constant, and then after putting it, you come and you cancel it out to find x raised to 4 plus 3x squared plus 3x plus c. So that's the integration of this indefinite integral. Now, With that, I can conclude that we have come to an end of definite integrals and indefinite integral. Next session, we are going to learn about how to find the area under the curve as I was showing you earlier, and how we may do it much more than what we have experienced. We shall now look at the area under the curve, and we shall look about one of the example which we did in 9.3 in differentiation using the trapezium rule. Now we are going to estimate that to use our integral method to find the exact area of that one from that given point. For instance, we had y equals to r half x squared plus 5, and then we were told to find it from x equals to 1 and x equals to 5. So that is what we had, and we found the area as 41 square unit. Now we shall use this method of integration to find the area under a curve, and we can find out that the area under the curve is only to find if this is my Cartesian plane. You have been instructed to find this is the curve y equals to x a half x squared plus 5. Then the area under the curve, you have to find it under the given intervals. For example, here our interval is x equals to 1, so meaning we shall start our area from that section. To x equals to 5. So my x equals to 5 lies at that point. So I'm required to find the area under this curve, the area under x equals to 1 to x equals to 5. The area under that curve, I can find it using the integral method by saying that I will find the integration of my y, and y is a half x squared plus 5 dx. I'm finding it with respect to x, but I have limits of integration, and the limit of integration here, my a is 1 and my b is 5. So having that one, we can simply and easily find the area, whereby I will take, that is a half multiplied by x raised to cubed over 3, then plus 5x plus c. But remember, you enclose it in a special bracket, and then you put the limits of integration here, starting with the upper limit, which is 5, and then the lower down. The lower one means we shall subtract what we find with that one. So here we shall now replace what we have. For first instance, we are going to get, this is 1 over 6 x cubed plus 5x plus c 5 1. That's what we are going to do. So in replacement of x with the 5, we are replacing, and we get 1 over 6, then 5 cubed plus 5 into 5 plus c. Actually, it should be just a bracket, not a special one, because I'm removing the constant of integration, the limits of integration. So minus because we are now substituting 1. So if I put minus, it is 1 over 6, 1 cubed plus 5 into 1, and plus c. From that section, we can identify that 5 cubed is 125, so we are going to have 125 over 6 plus 25 plus c. Then we subtract. Actually, it's better to remove the brackets. Okay, no problem. We shall remove. Minus 1 over 6 plus 5 plus c. So let's see what do we find there. This one is giving me 45, 5 over 6 plus c. So if I remove the bracket there, I'm going to get 5 1 over 6. Actually, if I remove the bracket, it's going to give you minus c. So 45 5 over 6 plus c. This plus c and minus c cancels out because they subtract each other, and then 45 5 over 6 minus 5 1 over 6, we are going to get 40 and 2 over 3 square units. But initially we found out using trapezium rule in area and approximation in 9.3, we found out that the area of this curve, we found from x equals to 1 to x equals to 5, we found the area being 41. But here we have found the exact area being 40, 2 over 3 square units. That is 40 and 2/3 square units. Now we can find any kind of given area so long as we have been given the equation of that curve and we have been provided with the limit of integration. If we have been given, it is just easy to substitute the integration limits, and then we find out the area, and we will have found the area under the curve so long as we take the conditions which we have been provided with serious. Thank you. We are going to see the application of integration in kinematics. And kinematics, this is just the application in movement of particles or bodies or any kind of body which is in motion. For example, we can see one of it. We say that if we are being given any kind of equation consisting of motion, for example, we may be given the velocity of a certain particle. If we are being given a velocity of a certain particle and we have been provided with the equation and we have been asked to find the displacement of that particle, then we have to integrate that velocity with respect to t. That is time. We shall be finding the displacement of that particle. And if it is acceleration, then we shall find the velocity by integrating the acceleration with respect to time. We shall see some of the examples here. For example, we have been told a particle moves in a straight line through a fixed point O with velocity 4 minus t. Find the expression for its displacement s from the point given that s equals to 4 when t equals to 0. So we have been told a particle moves in a straight line through a fixed point O with a velocity 4 minus t. So the velocity of this particle is 4 minus t meters per second. And then find the expression for its displacement from this point given that s equals to 4 and t equals to 0. So what we shall do here first, we need to integrate this one to find s, because to find v we say we differentiate displacement with respect to time. But here we shall now integrate velocity with respect to time. And integrating velocity with respect to time, we are going to take integration of v with respect to time, so it will be dt. But remember, we have been not, these units here which we have been provided with, they are not units of t. Because it is of t, only one t we have been provided with. Thus, we cannot fix them here as limits of integration. So, meaning our integration here will be an indefinite integral. So, we are going to have v as 4 minus t ms, that is the s now, it will give us the integration of v dt, which is the integration of 4 minus t dt. And this one is going to give us 4t minus t squared over 2 plus c. C is the constant of integration. But remember what? we have been told to find the expression of the displacement given that s equals to 4 and t equals to 0. So that means the displacement equation we have found is 4t minus t squared over 2 plus c. So in that displacement equation, we have been provided with the s as 4 and t, we have been told t is 0. So in anywhere where we have t, we replace with the 0, and here also 0 squared over 2 plus c. So we are going to find that our value here for c, this one will give 0, this one is 0. So the value of c is equal to 4. So we can rewrite our equation of displacement by saying is s is equal to 4t now here minus t squared over 2 plus c. But c, the value of c, we have found the value of c to be 4. So that is the expression representing the displacement of that given equation. That the initial velocity of a particle is given by the expression 9t squared plus 3 meters. The initial velocity 9t squared plus 3 meters per second. And then the initial velocity of a particle is given by the expression 90 squared plus 3 meters per second. Find the expression for the distance and hence find the distance covered by the particle during the 4th second. So what we should do, we have been asked here to find the expression that represents the displacement of this moving particle. So we have known that to find the displacement, which is s or distance, it is either distance or displacement. We are required to find it by finding the integration of v with respect to t, where our v here is our velocity which we have been given and t is with respect to time. So if we do that way, we are going to integrate 9t squared plus 3 with respect to t. And on integration, we are going to get 9 over 3 t cubed plus 3t plus c. And this one will now give us meters because we are integrating with respect to t. So our s or distance is equivalent to that. So we have been told, find the expression for the distance and hence find the distance covered by the particle during the 4th second. So during the 4th second now, we shall now take it as is it. Because we don't know the value of c, we cannot ignore c. And since we were not given the limits of integration at the same time, we cannot fix our own integration limit. So what we shall do here is, we shall replace what we have been told to find the displacement covered or the distance covered at the 4th second. So at where t is, we shall replace with the 4. So meaning it will be 9 over 3, but t is 4, so it t cubed plus 3 into t, which is 4, plus c. So we are going to find the displacement here now will be this one, it is 9192 plus 12 plus c, and we shall find the displacement s is equivalent to 204 plus c meters. It is that way because we can't not assume the value of c to be negligible, like 0, because we don't know what was the limit of integration, unless we have been provided with some conditions which can eliminate c. So the displacement or distance covered by that particle, it will remain to be that way. I come to a conclusion that we have learned how we can find areas of a given curve using integration, which are the perfect way of finding the area under the curve and it is always found by using the limits of integration which you will be provided with. Thank you for watching.